Hey everyone, in today's lesson from Chapter 6, we'll be taking a look at inequalities for two triangles. Our first theorem for today is called the side-angle-side inequality theorem. And it's kind of wordy and kind of long, but I think once you see an example, you'll get the hang of it. It says if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Right, so let's take a look at an example. Okay, so in our example we have AB congruent to DE. So if AB is congruent to DE and BC is congruent to EF, so those are our two sides of one triangle congruent to two sides of another triangle. And the measure of angle B, this angle, is greater than the measure of angle E. So we definitely have the included angle of our first triangle larger than the included angle of our second triangle. Then the conclusion that we could make is that line segment AC is greater than line segment DF. So if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So again, AC, the third side of the first triangle, must be greater than DF. We are going to take a look at a proof using this theorem. You won't be required to write any two-column proofs on your test. You'll just be writing a paragraph proof, the indirect proof, but this will be good practice to help you answer the questions on the homework. So we're given that D is the midpoint of line segment AC. So think about that. That means that line AD will be congruent to line segment DC. We're also given that the measure of angle 2 is greater than the measure of angle 1. So we definitely have an angle larger than another angle. And notice that the two triangles, the triangle on the left, ABD, and triangle on the right, BDC, share line segment BD in common. So we can use our new theorem to prove our statement that AB is greater than BC. So let's set up our two columns. So on the left-hand side, our first statement will be to say that D is the midpoint of line segment AC. And of course that was given to us. And you notice how I jumped right in and used the definition of midpoint. To mark line segment AD congruent to line segment DC. Okay. Before we go into the other piece of given information, let's go ahead and recognize that the other side, BD, which is a side in both triangles, is congruent to itself. So BD is congruent to BD by the reflexive property. And now we're going to say our other piece of given information, that the included angle of the first triangle, which is the measure of angle 2, is greater than the measure of angle 1. That's the included angle of the second triangle. Okay, so in step number 5, we're ready to make our conclusion. So we have two sides of this triangle on the left congruent to two sides of this triangle on the right. But the included angle of the first triangle is greater than the included angle of the second triangle. So therefore, we can say that the third side of the first triangle is longer than or greater than the third side of the second triangle. So finish off your proof by saying that AB is greater than BC. And that'll be the SAS, side-angle-side inequality theorem. And our second and final theorem for today, it's called the side-side-side inequality theorem. says if two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. So this particular theorem is used to make a conclusion about angles in a triangle. So let's take a look at this first example, then we'll see a proof. So if we know that line segment AB is congruent to DE, so that's one pair of corresponding sides congruent, and BC is congruent to EF, there's our second pair. What this theorem says is if we know that the third side, AC, in this triangle is greater than DF, the third side in this triangle, then we can say for sure that the measure of angle B must be greater than the measure of angle E. Okay, so if two sides of one triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second, then the included angle of the first triangle is larger than the included angle of the second. So you're using this theorem to make a conclusion about the included angles. So next we're going to take a look at how to use our new theorem in a proof. So we're given that BC is congruent to DC. We're also given that AB is greater than, the length of AB is greater than the length of AD. And I want to point out that these two triangles share line segment AC in common. Okay, so in step one, go ahead and include both pieces of given information, that BC is congruent to DC, and line segment AB is longer than line segment AD. So all of that was given to us. Next, in step two, put in that line segment AC is congruent to itself by the reflexive property. And then we're ready to make our conclusion already. We have all the pieces that we need. We have two sides of one triangle congruent to two sides of another triangle, and we're given information that the third side of the first triangle, AB, is greater than the third side of the second triangle, and that means that the measure of the included angle of the first triangle has to be greater than the measure of the included angle of the second triangle. So finish off your proof by saying the measure of angle 1 is greater than the measure of angle 2, and that's by using the side inequality theorem. As always, good luck on your homework, and let me know if you have any questions.